Hello, everyone, and welcome to today's event. Just a few housekeeping items before we get started. By default, everyone is muted to avoid background noise. If you'd like to submit a question, please use the question tab on the right side of your screen. We will address all questions at the end of each respective section and at the end of today's event. Just a reminder that today's webinar is being recorded, so you will automatically receive an email with a link to the recording after the webinar. If you find that you're having audio or video issues, please refresh your browser to resolve this issue. Just a reminder that today's event is through the browser, so there isn't a dial-in number, but if you are having troubles, please press the help button in the upper right-hand corner and a dial-in number will be displayed. All right, Rory, take it away.
All right, thanks a lot, Leah. Appreciate that. Just want to take a quick moment and introduce the speakers for today. My name's Rory Marsoon, and I work for Esko. I've been with Esko for around 10 years, and had a variety of different roles in the area of Flexo. So you could call me a Flexo geek if you want. My current role is Director of Business Development for our Flexo products. So I work very closely with the team who develops the products and also the sales teams to make sure that everybody is well supported in North America and Latin America. Brad, would you like to introduce yourself?
Yeah, thanks. First of all, good afternoon, everybody. Thank you for joining us for this webinar. My name is Brad Gaskew. I work for DuPont Image Solutions. I'm a technical service consultant. So what that means is I basically support our customers that use Cyro plates, and I go to them and help them problem solve or set up new materials and just help them any way I can. And fortunately for me, I was able to take a class under Rory Marsoon at Clemson whenever he was there teaching. So he kind of started this whole Flexo geek thing to me. So he kind of passed it down. And so I blame him for the addiction of looking at dots.
Very good. Good student too. So let's get started. So today, Brad and I are going to really present the solutions that Esko and DuPont have for the label market. And when we kind of look at our product line, we try and match that up with what are the label printers asking for in the marketplace. And we've kind of come up with a list of what we believe are some of the key things that label printers are asking for today. Number one, it always has to be at the highest level of quality. Number two, you have to be able to make a plate quickly. In today's fast-paced world, things have to turn around quick on the press. You get a job in, and maybe the same day you have to turn around and get on press and print it. And then we also have pressure from digital printing, which means that we just need to be faster and better in all aspects. Fast make ready, so when we get those plates on press, it needs to set up quickly and get up to speed, and we need to begin producing. Consistent and repeatable, so every day we need to get the same result. And of course, the environmental impact of our products needs to be minimal. I'm mentioning this because what we're going to do here is go through all of our different products, or not all of them, but say the most relevant ones for today. And at the end, we're going to try and tie together how those products really apply to these things that we hear our customers asking for. So the structure of our presentation today will really follow the plate making workflow. And obviously this is a very simplified version of that workflow, but these are the sections that we're going to kind of go through as we present. So we've got screening, which is the pre-press stage where we take our artwork and we make it into dots, and then we image. And then we have our exposure system and our processing system. But the first thing we're really going to start with is the plates, because that's part of the entire workflow. So with that, I'm going to hand it over to Brad and let him talk about plates.
Yeah. So like Rory said, this whole process, we have to have a plate for it. So we're going to start there, start with the polymer side of it. So you can go to the next slide, Rory. So a question that, I'm asked very often going to customers or helping customers set up with new plates is, what plate type should I be using? And I always joke with this answer of it depends in the Flexo industry, but it really is an answer I feel like we could use for like 90% of questions that we're asked, just because there's so many variables in the Flexo process. So it really does depend on your process, on your substrate, your press, your printing environment, what plate is going to work best. I always recommend, going through an optimization testing phase for choosing a plate. But here we have some just common plates that we see in the tag and label market. So these are thin plates, so like a 045, 067 gauge plate. So we have two different kind of plate types that we can offer, either fast thermally processed plates or solvent processed plates. So for the fast plates, these are kind of the three common plates that I see in the narrow web market. EFX, which is part of the Easy product family. We have DFR, which is a harder durometer plate. And then we have DFM, which is a softer durometer plate that's pretty commonly used on uncoated papers. On the solvent side, these are kind of the solvent sister plates to the fast ones. We have EPR2, which is an easy plate, DPR, which is the harder durometer plate, and then again, DPL, the softer durometer plate. But if you had to really twist my arm, make me choose, one plate to talk about today for labels in the tag and label market, I would definitely choose EFX. That's probably the most common one used. You can go to the next slide, Rory. So EFX is a really versatile plate that can be used for tag and label. It's kind of a medium to hard durometer, so like a 067 gauge, which is common. It's like 66 Shore, 67 Shore. So you can, it's a hard enough durometer that it can hold very, very small dots. So 175, 200 line screen, but it's soft enough durometer you can still use it on paper. Whereas traditionally harder durometer plates, they don't transfer ink well on paper. But this is just a good versatile plate. The durometer is really nice to print on any substrate. You can use it on UV inks, water-based inks, and even solvent-based inks. So this is the go-to plate that I would say for narrow web is the EFX plate. And really, in my opinion, I think this is one of the best plates that DuPont offers right now. Before this plate, thermal plates were kind of really not up to the par when it came to competing with solvent plates. But once this EFX plate came out and we started, developing more of the Easy family, this plate can compete all day long with solvent plates and print just as good a quality. It's really an impressive plate. Next slide. Next slide, Rory. Okay. So you asked, why does the printer need an easy plate technology? So I thought I would kind of just show kind of the difficulties or the issues that the printer has on press that would require or that would encourage someone to go to an easy plate. So on the left, you see these small digital round top dots. Once you squeeze those things out and give them good impression, you're going to see there's a lot of dot gain, and then the ink actually starts bridging between dots when the dot gain increases so much. It's not good. It's going to create dirty print, peppering. You can call that sometimes in the print. You see these big blobs of ink. You don't want that. And then also we have poor ink transfer. And that's just from Flexo. Traditionally, if you just have the polymer plate trying to transfer smooth ink film thickness onto a substrate, especially film, that's very difficult. And so we have technologies, thankfully, now because of Esko, like microcell patterns, that we can apply to solids to help us transfer more ink. And that really works best with easy plates. Next slide. So what makes easy plates really work well is the built-in flat top dot in the plate. And so the flat top dot technology is nothing really new. It's been around for a long time, but it's really been adopted really well in the wide web industry. And I feel like the narrow web industry, the tag and label market, has been a little slower to adopt it, but it's really beneficial, and I'm going to show you right now some of the benefits of why flat top dot's really good to use. So just the basics, you can see here on the left, the digital dot has that round tip to it. On the right, the flat top dot, there literally is a flat surface on the dot, and this allows us to really provide higher consistency in print. We can hold fine microcell patterns really well as really fine highlight dots. So that allows us to have smooth fades to zero, dense solids, and the Cyril EZ family really helps us do both of those. So I'm going to show you a little more in detail in the next slide. So I like to show these series of slides here to show you why flat top dot is important. So you can see these two plates here. The gray part on top of that plate would represent the lambs layer, the carbon mask. So the opening in both of those plates are the same size, but there's dot sharpening in that digital dot. And so you get that round tip to it. And the easy plate on the right is flat. It's just the technology built into the plate with no nitrogen, no laminating, gives us a flat top dot. So when you print these, next slide. So when you print these under perfect KISS impression in a perfect printing environment, you can see that small tip of that round top dot actually can print smaller than a flat top dot if they're same size. So a lot of narrow web printers that have really small presses, have really fine impression settings, have liked the digital dot because of this, because they can get really good KISS impression and print really tiny dots. But unfortunately, during production, this is not the way impression stays. Normally it goes in like this slide. So as you increase the impression on that plate, that round top dot has a lot of dot gain, where the flat top dot doesn't have as much dot gain. So it's much more consistent, the flat top dot is, when it comes to impression variation. So if you have different operators with different impression habits, you could have different dot gain from day to day or job to job with a round top dot plate. But with a flat top dot plate, you're going to have very consistent dot gain, just because there's a lot of latitude when it comes to impression. So that's one of the benefits of a flat top dot. The other is the ability to hold fine microcell patterns. So these microcell patterns have really helped us to have really nice solid ink density, smooth solids, no voids and barcodes. And you can see on the left, the round top dot one, it's really not holding these microcell patterns well. It's if you look at the gray image of actually the pattern itself, it's not consistent. The cells aren't opened up all the way. Where the flat top dots, the cells are very clearly opened, they're well defined, and those cells are deep. So if you, it's kind of blurry on my screen, hopefully it's a little better on yours, but the color gauge on the left-hand side of the image shows you the micron depth of those cells. So the depth of the cells of the flat top dot are over twice the size, twice the depth of the round top. So it's really creating nice microcell patterns so that we can transfer better ink. Next slide. So again, just going over a summary of the key benefits of the easy plates and why they should be used. Higher productivity. So there's a simplified workflow if you want to do a flat top dot. There's no extra equipment, no lamination needed, or no nitrogen needed to make a flat top dot. It's all built into the plate, which also makes it very consistent. And then you have that impression latitude, so it's very forgiving on press and is very consistent. When it comes to quality on press, you get improved solid ink density with the ability to hold microcell patterns, and you have excellent fade to zeros because these dots it can hold is very, very small, and they will not have as much dot gain as you see on a round top dot plate. So therefore, you're going to print lighter on press. And then it's going to be higher consistency from run to run on press because of the impression latitude as well.
All right, thanks a lot, Brad. So we're going to move into screening. Brad kind of started to touch on how the plate technology enables screening to function better. What I'd like to do here is just kind of talk about screening in general and kind of how we've evolved into where we are now. So there's a good bit of history with Esko and screening. If you know Esko, you know that we've been around for a while, and we've had all kinds of kind of unique screening technologies, which maybe came from different companies like Artwork Systems or others. And we've kind of got this huge collection of screens, and we've kind of always struggled with simplifying that for the user. So the original screening tool that we introduced in the marketplace was called Screen Manager. Some of you may have used it or still use it. It's actually a very powerful tool, but it's actually an R&D tool, and it allows you to build all kinds of different crazy screens and create dot sizes of and scatter the dots differently and all these things. But we quickly found that for most users, and doesn't matter what industry you're in, it's just really too much. And that's actually where HD Flexo was born from. HD Flexo is a technology that was actually released in 2009, so it's been about 11 years ago. And it was designed to simplify that process of determining what's the right screening for my application. And so this would generate a print target. You'd make a plate and print it, and then you'd analyze it and say, okay, this is the best screen. And it would allow you to install that screening into your RIP and start using it. And this is actually very commonly used today still, and we still sell it. The challenge is that as time has gone on, more and more technologies, like the one that Brad just mentioned with Easy Plate, the different flat top technologies, we've had to kind of continue to add new screening technologies into this system, and it's now become complex again, where you really have to know your stuff to be able to select the right screen. And so this is an example of one of the targets that we actually output out of HD Flexo. And what this is maybe 16 different microcell patterns combined with a dozen different highlight screens. And we print this target, and the user is actually expected to determine what's the right screening based on this. There are a lot of people that enjoy that, myself included. Actually, I wouldn't say there's a lot, maybe a few, but the truth is most people really don't want to have to look at all that and analyze it. So it's actually a combination of a visual analysis. So, you're going to look at it and use your own experience and your own perspective to determine what looks the best. You can also measure it. What highlight dot gives me the lowest dot area and gives me the smoothest fade to zero. And then once that's done, you actually have to apply that screening to a fingerprinting process, or maybe even your characterization process to do your color management. So there's quite a bit of work that really has always had to be done to dial in your screening and your dot gain curves. Okay, and this is an example of a manually created curve. So, I love making curves. I think it's awesome, but it's also one of those things that not a lot of people are really good at because they don't do it very often. And the truth is, if you make a bad curve and apply that to your artwork, it can completely devastate the quality that you get out of your imager and your prepress. So that brings us to our newest product, which is called Print Control Wizard. Print Control Wizard is really designed to simplify and really automate the process of creating dot gain curves and selecting screening technology. And what this means is you can spend less time doing all the testing and analyzing and all those things. And so it actually can reduce the cost of setting up a new Flexo project. Maybe every time you get a new substrate today, you're having to run a new test and determine the new screening that you need to use. You can kind of speed that up with this product. And you can combine that also with Print Control Wizard, actually including the newest screening technology available, which is crystal screening. So crystal screening is not available in HD Flexo. So this is kind of like the evolution of HD Flexo. And it, you know, as I said, includes the latest screening technology, which I'll talk about a little bit here. By the way, Mark Samworth and Corey Devlin are going to have a presentation tomorrow where Mark has probably 140 slides on some of these things. So I'm not going to go deep here. I'm going to let Mark go a little bit deeper. He's very good at that, as most of you may know. I just want to touch on, you know, exactly what is this product. So what we see here is the target that might be generated from Print Control Wizard. And the fact is that then gets measured on the I1IO, and the software takes that data and automatically does all the number crunching. It uses some very smart algorithms to tell you what the right screening is, you know, and what's the right curve for that particular application. All right, so it's super easy. Anybody can do it, and it saves a lot of time. So crystal screens are the screening technologies that are generated out of Print Control Wizard. Print Control Wizard has different applications, we actually have different product offerings. So we have screening for flexible packaging. The very first version of Print Control Wizard, which was released with version 18, really focused on flexible packaging. We now, as of maybe 3 or 4 months ago, I think June, which would have been 3 months, let me do the math right, we released version 20, which includes a version of Print Control Wizard, which is designed for labels. Right? I know this is not a session for corrugated, but coming in later this year, we'll have screening for corrugated. So we're going to continue to evolve this product and add new screening and develop that screening technology. So let's just quickly look at some of the results. Now, what I want to just say first is that with Print Control Wizard, it's going to select the right screening for your application. Some of the screens that I'm showing here may not be the same screens that you would use in your application. It's going to depend on what analogs you're running, what substrate you're running, what kind of press conditions, sticky back, and all those things. So what you're looking at here, these are some samples that were printed on film at an actual label printer. And again, Mark will go much deeper in this tomorrow. But just to give you a taste of what we're seeing in the label market, we're looking here at solids. So on the left, you have a solid with no microcell patterning, and on the right, this is the crystal screening applied. And we look at the type, and we start to see some really striking differences here when we start to understand kind of the power of the screening technology. On the top there, that's actually very normal for Flexo. I think if you ever went to a class about Flexo, you learned how to identify Flexo, and it's look for the halo, right? So it's not abnormal to have a halo. It's not wrong. It's not bad. But with crystal screening, we're actually able to get a much sharper, cleaner edge, which also can clean up your reverses and things like that. And then we start to look at our dots, and this is just a mid-tone dot here. And you see the same type of effect, but you start to understand how this screening is going to give me more predictable results, because the dots are more, let's say, consistent and contiguous. You don't have different shades of ink throughout the dot. It's one smooth ink laydown for the dot, and the edges are very sharp. You've got a clear distinction between dot and paper that you don't generally have with fluid inks and Flexo. So there's a lot of power here. You're going to get much cleaner tone reproduction. You're going to stay cleaner on press, less dot bridging and things. So very interesting results we see here. And again, Mark Samworth and Corey Devlin will, during their presentation, really go deeper into that. So now transitioning over to the next step of the process after screening, which would be imaging and exposure. It's actually two separate steps that I'm going to kind of combine here. If we look at a timeline here, it goes pretty far back when we look at our imaging technology. It all started in 1995, and the very first CDI, the Cyrel digital imager, was a joint development between DuPont and, at that time, it was Basel Shield and Barco, which now is Esko. So the partnership that you're seeing presented here between DuPont and Esko goes back many, many years, and is now as strong as ever. But the very first CDI was brought to market by DuPont and Esko. Over the years, we have evolved that technology and expanded our installed base. We see that we implemented the fiber laser technology in the year 2000, which is still today what we use. Very, very stable, consistent, actually the most consistent way of imaging a Flexo plate. We then started ramping up our resolution capabilities with high-res optics, and which we still sell today. We even have technologies that are designed for security printing that go to 8,000 DPI or maybe even a little higher for certain applications where that resolution is needed. And then we started really getting into exposure. So you may or may not know this, but with LED exposure, it's something we talk a lot about today. That is not something new for Esko. We launched the first inline UV LED exposure system 12 years ago. And so we've got a ton of experience in that technology. HD Flexo and Full HD Flexo are both very commonly known brand names in the world of Flexo. And we're very proud of those products. And still today, HD Flexo, we would say is a standard in terms of quality. And HD Flexo is really a combination of high resolution imaging and our advanced screening technologies. And then some of the things we're going to talk about here, the CDI Crystal, and we've already mentioned the Print Control Wizard. So today, our installed base is now approaching 4,000 units globally. We're very proud of that and hope to continue that trend in the future. So our general CDI product offering, we have really two families of CDIs. The Spark family, or the Spark and Cantilever family, and then the Crystal family. The Spark family, we still sell these products. It's still very high quality product. We still put our latest technology into these machines in terms of optics and high resolution imaging. We have many different sizes. We have all kinds of different speeds that you can get these machines at. So you can get a smaller machine with faster optics, a bigger machine with slower optics, or a big machine with fast optics to get the right yield on the plate and also the right throughput with the right speed. So very modular in terms of how you can configure this. The Spark family is really known as the workhorse. These things have been around for a while. They're very well proven in the marketplace, have a track record of being rock solid machines. They're hard to beat in terms of just working on every day. The Crystal product line was announced and shown at Drupa 2016 with the CDI Crystal 5080 and XPS Crystal 5080. And then a couple years ago, we also added the 4835 format of those devices. These devices are really, we'll get into the XPS, but the Crystal platform is really about automation and simplicity. We're going to talk a fair amount about that as we move through the presentation. You can see they look beautiful. That's another thing. We actually had an industrial designer involved in the process when we designed these machines. Really impressive to see these machines in action. And here in a little bit, you'll actually get to see a demonstration of that machine. Or those machines together, I should say. So again, kind of just touching on the surface of the XPS, there will be more detail tomorrow. What is the XPS crystal? Let's first define what it is. It is an exposure unit. It does main exposure and back exposure simultaneously on the plate. And it's using UV LED diodes to do that. The UV head moves across the surface of the plate. So you see in the image here, you've got the green box here. It moves across the plate, and it moves, you can change the speed. We can change the amount of intensity of the light that comes out. And also we can change how many passes we make over that plate. And it's a touch screen that has, and the system really has all the settings you may need for the most common plates that are used today, so that you're not having to kind of create your own formula for exposure. We do all that work ahead of time and give you the parameters so that you're really plug and play with the system. So if I were to summarize really the key benefits of the XPS, it would have to be these three things. Consistency. Anytime I talk about the XPS, the number one thing that I have to talk about is consistency. We're using LEDs as opposed to the traditional tubes in a backlight exposure system. Tubes are known not to be consistent and not to be stable. And we also know that as time goes on and those tubes wear, you use them, let's say, a few hundred hours, they get weaker and weaker and weaker as time goes on, until one day they're at a point where you're no longer able to make a good plate anymore. With LEDs, you really don't see the same change in output the way you do with bulbs. So with XPS, what that means is every time I hit the button to expose a plate, I'm going to get the same result. I'm going to get the same result across that plate. I'm going to get the same result from one plate to the next. And I'm going to get the same result from one day, today that I would get like 6 months from now. So there's no having to worry about adjusting settings and really tweaking things to continuously get the same result. We do talk about quality in general. We see that there's some improvement in quality with the XPS over a backlight exposure. That can look like maybe some smaller highlight dots. Maybe we're able to print a little bit smoother gradient and vignette. Some plates we see more of an incremental improvement in quality than others, but we can say as a blanket statement that we generally do get better quality in terms of just print quality from the XPS. And the last thing we like to talk about is if you're interested in automation, automating the plate room, it all really goes through the XPS. All right, and you'll see how that's going to work here shortly. So these systems can work independently. So here you see a picture of the XPS in a standalone mode. So if you have an existing CDI, it's not a CDI crystal, maybe it's a Spark, or maybe even a competitive device, you can add an XPS and use it as a standalone exposure system. That's no problem. But you can also, with the CDI crystal, connect those two devices. And in this configuration, it's still a manual workflow, except it's much easier to move the plate from the CDI to the XPS. You can just slide that plate over. You don't have to put it on a cart. You don't have to pick it up. So it's a little bit easier for that user to move that plate. But what I'm going to show you today is the plate handler, which is a new technology that's available that allows the system to actually automatically move the plate from the CDI to the XPS. You'll see the demo of that here shortly. But when we talk about automation, we know that this is not automating the entire workflow, but there are benefits to just automating this part of the workflow. So if we start to compare the existing process, you may not even realize how many manual steps there are in that process. So in this image, we're showing, you're getting the plate from storage, you're taking it to back expose it, you're moving it back to the imager, then you're putting it back on the exposure unit to do main exposure, then you're going to put it in the processor. So there's, in every one of those steps, you got a person moving the plate physically. With our system, with the automated system, really you have a person putting a plate on the CDI, walking away, and it does the rest up until the point where it's ready to go in the processor. This is another view of that. So this is a diagram that's showing every step of the plate making process up to the point where it's ready to go into the processor. And this is today's existing process. This is actually making 2 plates. And you can see all these different steps. Retrieve the plate, warm up the exposure frame for back exposure. This one's really interesting. Wait for operator. So this is something we don't think about. But when you expose a plate, back expose the plate, a lot of times the operator will hit the button and walk away and then come back. And it may not be at the exact moment when it's finished. It might be a few minutes later. So in this case, we've said, all right, it's going to take the operator 2 minutes to come back to that machine. And honestly, it's speaking to a lot of folks, that's a pretty conservative number on average. So we have all these steps. What I'd like to highlight here is all these steps that I've circled. When we automate with the plate handler and the CDI crystal and the XPS, all those steps that are highlighted are no longer needed, which means the operator doesn't have to do all these other things. And this is what the process now looks like. So the operator comes and gets the plate, loads it onto the system, and walks away. And then once that plate then moves from the imager to the XPS, they can come back and load the next plate into the CDI. So the plate making process is much less demanding on the operator. You'll also see that from a time perspective, it is a little faster than a manual workflow. Part of that's because main and back exposure are happening at the same time. Part of that's because we don't have those times where we're waiting for the operator. All right, so we actually calculated here that in 8 hours we can do 21.2 plates, whereas with the manual processor we can only do 18.4. So let's say an additional 2.5 plates per shift, which can be valuable for a high volume facility. All right, handing it back to Brad for processing.
Cool. All right. So when it comes to processing, we've had a lot of technologies and improvements in our processors, just like Esko has in their imagers and exposure units. So I'm going to just go over really one of our technologies, the fast processor. Next slide. So the fast system is a thermal processor. So with photopolymer Flexo plates, you can process the plates a couple of different ways. So processing is just taking away the unexposed polymer from the plate so you have a relief. So you can do it with solvent and a series of brushes to wash away the unexposed polymer. Some technologies use a water wash, so it uses a chemistry and brushes to do it with more water and not solvent. But here we use thermal. So we use a combination of pressure and heat to basically melt away the unexposed polymer and then absorb it into a non-woven material and wick it off the plate. So it's a completely dry process, no solvents, no water, which makes it faster, as the name calls it. So next slide. So this is just kind of a technology roadmap of what DuPont has done, since the 70s in the Flexo industry. I'm not going to go through every one of these points and tell you all about all the amazing things that DuPont has done to advance the Flexo industry. but just wanted to point out a couple of them. So in 1974, the first photopolymer Flexo plate for the fast thermal developers. In 2000, we released the first eco-friendly thermal processor. And then in 2008, we released fast in the round. So that's actually sleeves, so in the round sleeves that are thermally processed. Really cool technology that's allowing us to convert business from rotogravure. So really in the wrapping paper business right now, we're converting a lot of business from gravure to fast in the round, which is really cool. In 2014, we released the 3000 TD fast processor, which that's the big boy, that's the 5080 format machine. It's a beast, really, really nice machine. And then in 2016, our next generation fast processors with the 2000 TD was released. And that's what I'm going to be talking about over the next couple slides. Next slide, Rory. All right, so for the past 20 years, we've really improved and learned a lot about thermal processing since we were the first ones. And with each generation and each machine we've released, we get better and better. So right now we have over 1,500 fast processors installed globally in over 80 countries. And with the new next generation 2000 TD fast processor, we have over 100 of those installed over the past 4 years. So slowly growing that next generation fast processor. Next slide. So the Cyril fast system as a whole really has been a favorite among our customers for a couple of reasons. One of them is it's a complete hardware and consumable solution. So we sell the customer everything. We provide everything from the machine to the plates to the non-woven. And then we are actually a Esko reseller. We're actually the largest reseller for Esko products. So we actually can put a turnkey plate making solution together for our customers, including the CDI, the software, the Kongsberg cutting table, and all the plate making equipment, and provide them a whole system of plate making. We have superior process control, excellent product quality, and proven consistency with our plates. And then combined with our new easy plates, with this new next generation processor, we really have created a product that is like none other. It really is impressive for higher ink transfer, really small highlight dots, all doing that with no solvents and making a plates in less than an hour. Next slide. So just introducing the 2000 TD fast processor. This is the replacement processor for the 4260 format that we had in the previous generation. So this is a 42 by 60 format processor. It's an environmentally friendly plate making system that, like I said, has no solvents involved in it. It's completely dry. It's one of the fastest plate making systems in Flexo. And it really does fast thermal processing, really allows some of even the smallest printers to have in-house plate making, where with a solvent plate making process, it'd be very difficult for some printers to benefit from having in-house plate making, just because you have larger equipment, you have chemistry involved, you have to worry about reclaiming solvent, and with this, you really don't have to. You have an imager, an exposure unit, and a processor, and that's it. I have customers that have this equipment basically in hallways. I have one customer that has it set up in a hallway just because the footprint's that small, and it really is impressive, the footprint and the usability of this equipment for smaller printers, and even larger printers for the large 5080 formats. For plate suppliers or for larger printers, if you're pumping out a lot of plates, you can install 3 or 4 of these things and pump a lot of plates out in a day. Next slide. So these are just some of the key equipment features of the new 2000 TD. we're going to show a demo video here in a minute that's going to walk you through the processing process, but these are just some of the features before you watch that video. So it has a simple operation via a touchscreen. It's really nice. It doesn't give the operator anything that's not needed. So you're not going to have an operator hitting buttons or changing menu options or processing conditions they shouldn't be touching. That's all locked out. So they only have to see what they need to see to process a plate. It's basically a go button. It's really nice. The way we hold the plate on this processor is completely different than how we did in the previous generation. So if you've seen these processors before, we had a drum that had this compressible skin on it, and the plate was clamped on the front, and then the tail of the plate was actually free, but it just stuck on that tacky drum. The way this processor works is it actually has a pin system that punches the lead and tail edge of the plate, and then it puts a little bit of tension on that plate so that it holds it flat. So that really makes dimensional stability really nice because it's holding that plate under the same tension the entire time. It has optimized heat management in it, which is really nice. It helps for a more consistent processing, more consistent relief. The impression cylinder, like I said, is different. With the old cylinder with that compressible material on it, you would have to repaint it as a PM from time to time. With this machine, there is no shutting it down and having to repaint a drum. Whenever the compressible sleeve, the compressible impression sleeve needs replacement, it's literally you open the side of the machine and you slide the sleeve out and you slide a new sleeve on. So it's really quick and easy. Remote diagnostics. I made this one bold because I think this is a really unique feature, especially now during the times with COVID, when a lot of customers don't want technicians in their plate room, if at all possible. So we can actually do a lot of training. We can do setup of materials and troubleshooting with this machine remotely, which is really nice. We've been doing that a lot over the last 6 months with this pandemic, doing a lot of remote training and setup of these machines. Low VOC emissions, low energy consumptions. This thing is environmentally friendly. It's a perfect fit with the Cyrel Easy Plate portfolio. So with the combination of our new technologies and plates and the consistency that this processor gives us, we can have a really beautiful thermally processed plate. And then the plate size varies. The largest format it can do is a full 42 by 60 sheet. Smallest plate size it can do, you can see there is about 24 by 18 inches. And we can even adapt it. So if you don't, say you have a 35 by 47 format that you use, we can adapt it so that it takes the smaller roll of non-woven. So you're not wasting so much non-woven material on there. Next slide. So this statement here is kind of, I think, really wraps up the whole mindset behind how we develop new equipment. At DuPont, sustainability is at the core of what we do, from reducing our operational footprint and creating market-facing sustainable solutions to addressing the global challenges of the future. So we really do take in, the environmental consciousness whenever we develop equipment, develop products. We want to make sure that we're doing the best that we can for the footprint that we're leaving on in the globe. Next slide. So this is pretty cool. So the VOC emissions, when comparing to solvent processing plates, really is impressive to see the difference between solvent processing and fast processing. So the first generation of the fast processors, we reduced VOCs by about 98% compared to solvent. With the latest generation of fast processing, we reduced that another 76%. And so we're 99% reduction compared now to solvent. The way we did that was we have tighter control with temperature, so we can monitor temperature much better now compared to the first generation. And then we have an improved CADOX system that's going to help us burn off any fumes or any kind of condensation that's in the exhaust before it goes out. So really impressive VOC emissions. Next slide. So just a little summary of the thermal processor and the 2000 TD. So faster processing. So the productivity really is impressive for just-in-time plate making. So instead of making multiple plates for a press run that might need a backup, you might not have to do that now. You make one set, and if you need a set on press, then you can easily make a plate, a remake in 45 minutes to an hour. There's no drying time because the process is completely dry. There's no liquids in the process, so there's no dryers to worry about. It's very easy to operate for the plate makers, which is really nice. There's no balancing of solvents to worry about. There's no cleaning of the machine or making sure the brushes are clean. You just put the plate in and it processes and comes out, and you change the non-woven. It's very easy and simple. Cost savings, so reduced downtime in the plate making process, and then reduce waste treatment because there's no solvent to have to worry about. The non-woven material, whenever it gets full and you have to change a roll, you collect that non-woven material, and then DuPont will actually come pick it up, and we will use that as an energy source in manufacturing. Reduce energy consumption, very compact design, like I said, so you can fit these machines into pretty small rooms just because they're not large. And the environmental footprint is very important to us. Up to 53% less greenhouse gas emission, up to 63% reduction in non-renewable energy consumption. And it completely eliminates the solvents from plate making, and it's just more energy efficient. And like I said earlier, the VOC reduction compared to solvent plate making is really impressive. So it's a great plate making process and equipment that really is combined with our easy plate technology can compete with any other plates or plate making processes.
Okay, as we wrap up here, we're going to come back to some of the things that we showed in that very first slide. You know, what are the important things for the label printers? At least what we're hearing from the label printers today. So if we kind of look at this and we say, all right, quality must be top notch. What are the different things that we just talked about that, you know, address that need? Well, we can think of a lot of them, right? So with the DuPont plates, we've got the new Easy plates with flat top dots, and Brad highlighted the EFX plate. The XPS with LED exposure can enhance that quality. The CDI with the high resolution imaging, you know, the consistency, the stability there, and then crystal screening. And when you really kind of combine all those different technologies into a package, there's not anything with a higher quality level than that.
Yeah, when it comes to the quick turnaround time for plates, combining the products from both Esko and DuPont, you really can't have a quicker turnaround time. So when it comes to the exposure, there's no pre-warming of your bulbs prior to back exposure, which that can take up to 2 to 3 minutes sometimes. And then there's actually no, you know, taking the plate and putting it on the exposure for the back exposure step by itself, because it's done now simultaneously with the main exposure. So that's saving you a ton of time. With the fast processor, the whole processing steps and process is much quicker than any other processing out there, with no drying involved. So you don't have that, you know, hour and a half, 2 hours of drying that's needed with solvent processing plates. The automation really is a great feature here too, with the Esko CDI crystal and XPS crystal with that plate transporter arm. To have that plate not touched, you know, more times than needed, and have an operator just lay that plate on the CDI and be able to walk away and come back and it's already exposed, ready to process. That's a huge time saver to really help that quick turnaround time for plate making.
Yeah, and then, you know, fast make ready. So, you know, new plate technology. Brad highlighted the flat top dot and how it helps with impression latitude, so that the operator doesn't really have to have so much finesse to get the dot gain where it needs to be. Crystal screening, we've seen customers who, you know, they're able to really put that plate in and get up and running, match that proof, and have a very fast make ready. So, I think we've definitely checked this box as well.
Yeah, when it comes to consistency and repeatability, I always tell people with Flexo, this is like the key. You have to be consistent and repeatable. Even if you're consistently bad, we can kind of fix that in pre-press and make you a good printer. But if you're good, bad, good, bad, good, bad, then that's not good for Flexo. You're not going to be successful. But the fact that we're consistent and repeatable and we're very good is really going to help us be good Flexo printers. So the easy plates with the built-in flat top dot technology, that means that the flat top dot portion of that plate is going to be very consistent. It's not going to rely on any other, nitrogen or their lamination that's needed to make that flat top dot. And the XPS, man, that thing is by far the most consistent exposure unit you can get with the LED diodes compared to the UV fluorescent bulbs. So much more consistent. When I go on the customers to help problem solve print issues with their plates, so many times it ends up being that exposure unit because those bulbs are old, because they've fallen below the threshold that we like them to be at, or that they're just very inconsistent across the bed. So the consistency of the LEDs is really nice for consistent and repeatable. The CDI, that fiber laser, continues to be the most consistent laser in the industry. So it's good to have consistent imaging. And then the new fast processor with improved temperature controls, improved clean out with the way we don't have that traditional drum we had. We're going to have very consistent and repeatable plates from plate to plate, from job to job, day to day.
And Brad just got finished in his last few slides talking about the environmental benefits from thermal plate making. On the Esko side, the LEDs certainly can help here as well with the cleaner energy consumption. We're not wasting as much. There's not as much heat generated. Also, fluorescent tubes contain mercury, which is a hazardous material, and LEDs do not. So, when it comes to disposal of an LED, it's perfectly safe to, dispose of that in a landfill, and it will not be contaminating the environment. So with that, I really do think that, hopefully we've painted a nice picture of the solution we're offering and how it can really help the label printer in today's environment. With that, we're going to move into our questions. We've got a couple folks here to help us with questions. So,
yes, this is one question we have. It's for Brad. Have customers seen the thermal developer roll textures appearing when printing on flexible or shrink materials using the Cyril EFX plate?
So the EFX plate compared to the previous generation plates shows greatly reduced non-woven pattern. Is it there? If you get a really high power microscope, you're going to see a small pattern, but compared to like the previous generation plates like DFR, it is almost not there. So customers that have complained about seeing the non-woven pattern in the print before using EFX, when they switch to EFX, they no longer see that. It is just not there normally. So it's either greatly reduced or just completely eliminated. I haven't seen non-woven pattern printed with EFX in a very, very, very long time, if at all. Hopefully that helps answer. And also when you combine some kind of microcell pattern on the surface of that plate, that breaks it up even more, and it's going to be completely gone at that point.
Okay, thank you.
All right, a couple more questions from the crowd here. Rory, what type of ink was used on that crystal screening test form?
On the samples that I was showing, they were UV. It was UV ink on that film substrate. And in fact, most of the work that's been done with Print Control Wizard and the screening there has been with UV. Although there's not much reason why we wouldn't see some of the same benefits with water-based ink. Okay.
The second part of that question was, if it was UV, was it LED or conventional UV?
I don't know the answer to that question.
Okay.
that I would say to the person who asked that question, if you could re-ask that tomorrow with Mark Samworth. He was the guy who was on site there, and he'll have a little more detail on that.
Okay. Another question just popped in, Rory. This one goes to you. When will the 4260 crystal be released for sale?
So the 4260 XPS, it actually should be available very soon by in sometime in Q4, early Q4 probably. So we're looking at maybe a month out or so. The CDI Crystal 4260, we're looking at sometime in the early part of next year. So, and at that point we'll be offering the combined solution of the CDI Crystal XPS 4260.
Okay. Let's see here. What else we got here? A couple more of them. For sake of time, I won't maybe not be answer everybody's, but for customers that have HD Flexo already, why would they look into the Print Control Wizard? Can you explain the differences between the two?
So Print Control Wizard as a software offers just the simplicity of printing a target and measuring it in with an I1IO and not having to do any kind of manual analysis, right? So it simplifies that process. From a screening perspective, we do offer some different technologies that weren't available in HD Flexo. To be fully transparent, there are some technologies in Print Control Wizard that are very similar to what we had with HD Flexo. So it's one of those cases where it kind of depends on which screening technology you're going to end up with to say whether or not you're going to get a big benefit in terms of new screening. But for sure, just from a workflow and usability perspective, you're going to get those benefits.
Okay, two questions. I'll ask the first one for Brad. Can all the microcell patterns be used when incorporating into a fast plate? And again, it's a question also related to the non-wovens as far as any differences that you see on the 2000 TD versus the older generation of the fast processors.
Okay. Yeah, so with the 2000 TD, it absolutely does help reduce the non-woven pattern compared to the previous generation processor. With the more consistent temperature control and the way it cleans out the plate better with a different drum and that compressible sleeve, the non-woven pattern is also reduced even more. So in combination of the 2000 TD and the EFX, that non-woven pattern is, like I said, it's basically eliminated. I haven't seen that at all when using those two in combination. When it comes to the microcell patterns on fast plates, some of the microcell patterns require flat top dot. So you couldn't use some of those patterns on like DFR that's just not a flat top dot plate. But otherwise, as long as it's a flat top dot plate, you can use any of these microcell patterns. It will definitely hold them.
Okay, and another question is, can you speak about the quality differences between thermally processed plates and solvent plates?
Yeah, so some people think that since the thermally processed plates have a different texture on the floor, just how from the processing, it doesn't leave a smooth, shiny floor like you see in solvent plate making. That really doesn't matter because thankfully we don't print the floor. All we do is print the tips of the dots and the printing surface of the plate. So that doesn't impact the print quality. And in combination with our new easy plates and our new fast processor, the 2000 TD, these thermal plates will compete and print just as good as solvent plates all day long. And even the small highlight dots that people traditionally didn't think thermal process plates could have, these EFX plates will hold very, very small dots and very small text and features.
All right, I have another question here, probably for Rory. Is it possible to use the new i1 Pro 3 with Print Control Wizard?
That's a fairly new product. I'll have to check on that. I can get back to the person who asked that question after I do a little research. I actually don't know the answer to that question.
Okay. Last question so far, unless somebody has any more to type in. We've got a little time left for additional questions if you guys have them. Let's see. Expected lifetime of LED diodes.
So LED diodes from the manufacturer always basically says we expect about 5,000 hours out of those diodes, which is quite a bit longer than what you typically get with tubes, which is somewhere between say 500 and 800 hours. But what we have seen is that a lot of folks that are using these diodes, those diodes actually last a lot longer. We've got some that are up into the nearing 20,000 hour range, but it's one of those things where it's hard to predict when that threshold is. So it's I would say at least 5,000 hours in general.
Okay. Let's see. We got another question just popped in. What about the longevity of the plate solvent versus fast?
Yeah, so I haven't heard or seen any situations where a fast plate doesn't last as long as a solvent plate. But like I tell people, a lot of times plates, you don't really reach the end of their life on press. They end up getting damaged before they actually, quote unquote, die. So the longevity of the plate, yeah, as long as you're, not beating them up on press or cleaning them with shop rags and harsh chemicals, they're going to last just as long as a solvent plate.
Okay, great. I think we're about done on time here. Switch up and move over to the next presenter. Remember, folks, if you have other questions, by all means, type them in here, and we will get back with you, whether we answer them directly today or follow up afterwards.
Okay. Well, thanks for helping us with the questions, guys. So at this point, we're going to move into some videos, which is really designed to be a demonstration of our technologies, to give you an opportunity to really see them in action. The first video we're going to show here is of the Esko solution, and unfortunately, it's got my voice in it. So yeah, but it is. We've never really shown this before. It is the automation in the 4838 or 4835 format. And it's maybe a little different than what people saw at Drupa a few years ago. So with that, I'm going to go ahead and get that video started. After the video, I'll hand it over to Brad. We'll show their video, and then we'll take questions again after the two videos have played. Today, we are showing a demonstration of the CDI Crystal XPS 4835, which shows the combination of the CDI, XPS, and plate handler to automate the plate making process. Here we see the operator taking a plate and removing the cover sheet. You'll see where he aligns the front of the plate to the front of the CDI, and there's a pin on the left side which he will align the left side of the plate with. This makes sure that the plate is exactly in the right location for loading. Once that's finished, he selects the job on the touchscreen of the CDI, tells it to start, and is able to walk away. At this point, the machine takes over. You'll see a small door open in the front of the machine, and it will drop the plate down onto the drum. And what you really can't see here is that the clamp of the drum opens, positions itself on the plate, and closes itself, and then begins to pull the plate into the CDI, exactly how an operator would do this manually. Once the plate's pulled onto the drum, the clamp opens all the way and allows the trail edge of the plate to fall back down and under the clamp. The CDI now begins to image automatically. The CDI Crystal is equipped with the latest imaging technology, including high-res optics, which allows us to image up to 5080 dpi, HD Flexo, Pixel Plus, and the ability to image our latest screening technology, crystal screens. We've now skipped ahead, and we'll watch the machine start to unload the plate. What we don't see here is the drum is now positioning itself properly. The clamp is opening and releasing the trailage of the plate, so that when it's time, all that has to happen is the drum has to reverse itself in the opposite direction that it did when it loaded the plate to push the plate out onto the loading table. Let's watch as this happens now. The system will now release the lead edge of the plate, exactly how a manual operator would do this. Opening the clamp, pushing the plate forward, backing the clamp up, and then closing itself back down. The last step of the process is that the small door will then shut again. Now the plate handler is going to move the plate over to the XPS. It begins this process by detecting the edges of the plate on both sides and also detects if the plate is exactly straight or not. This allows the system to accurately lift the plate regardless of the location of that plate on the table. Suction cups now very gently lift the edge of the plate and pull that plate backwards into the center of the table and the exact correct location for exposure on the XPS. The system now moves to the other edge of the plate, where it will again lift that plate and move it over to the XPS. The plate handler now repositions itself in its home position, and we will then see the XPS automatically go into the exposure cycle. Exposure on the XPS has many variables. We can control the speed of the head, the intensity of the UV light that comes out of that head, and also the number of passes that that head will make across the plate. It all depends on the type of plate material that's being used. Those settings are determined by our certification team located in Germany, who does many types of tests to determine exactly what the optimal settings are for each plate type. We are now going to speed up the video while that exposure continues. I'd like you to recognize that the operator has still not had to return back to this machine. The system loaded the plate, imaged the plate, moved the plate to the exposure system, and is now in the middle of doing main and back exposure. And again, that operator's been busy doing other things, whether it's pre-press or some other function in the plate department. We now see the operator returning back to the system to load the next plate into the machine. This can happen as soon as exposure begins. This allows a streamlined, continuous plate making process. Also notice how little time the operator must spend at that machine each time he comes back. This allows that operator, again, to be busy doing other things in the plate department. All right, so that's the Esko video, and I'll hand it over to Brad to introduce the DuPont video.
Awesome. I mean, that thing's super impressive. That arm is really nice. So this video,
What is displayed in the screen is DuPont's Fast 2000 TD. What is displayed in the screen is DuPont's latest new generation of solvent-free thermal plate making system, DuPont Cyrel Fast 2000 TD. The plate loading table is located on the top cover of the equipment. Operators can easily lay the plate on the top cover of the equipment and gently push the plate into the loading port with both hands. When the plate is positioned in place, the indicator light will change from green to blue. Next, the operator can select the plate type, thickness, and width on the operation panel, and then click the Start button. The automatic plate loading mechanism will start and firmly fix the plate to the front swing arm. The plate moves forward following the front swing arm and around the virtual central drum. At the same time, the equipment automatically measures the length of the plate. When the plate tail enters the equipment, the plate loading system will operate again and fix the tail to the rear swing arm of the equipment. The front and rear swing arms work together to drive the plate around the central drum. When the front swing arm carries a plate along the heated roller, the heating roller contacts the plate surface under the precise control of the servo motor. The non-woven fabric takes away the melted uncured resin. At the end of the plate, the heating roller will lift up in time and return to the standby position. We can see that after a cycle of processing, the plate lambs layer on the plate surface has been completely taken away by the non-woven fabric. On the front operation panel, the number of plate cleaning cycles and the current position of the plate are displayed in real time. When the heated roller is in contact with the plate, a small amount of resin vapor will be generated, and these vapors will be sucked away by the gas collection device located above. The built-in K-Tox catalytic unit of DuPont Cyrel Fast 2000 TD will decompose the steam at high temperature. After the printing plate is cleaned with a set number of cycles, the uncured resin has been completely taken away by the non-woven fabric. At this time, the equipment will automatically exit the cleaned plate from the machine, but the plate tail will still be fixed on the rear swing arm, waiting for the operator to remove it.
sorry that video started very abruptly and very loudly. And just so you know, that was not my voice. I don't talk that way, but that was the 2000 TD demonstration.
Yeah, sorry for the little technical glitch there. Did you want to introduce it now, Brad?
No, you're good. Nope, I was going to say it's the 2000 TD that I mentioned in my presentation earlier, and that you were going to see the operation of it, but you just saw it. And I was going to tell the viewers that it was not my voice, but hopefully they realized that.
Okay, so I think we have some few questions. Sean, do you want to ask them?
Yeah, it looks like we had a question for Rory related to the material handling, the feeding, the suction cups feeding the plate material in. Attendee wanted to know if the suction cups affected the imaged area on those plates.
It is a good question. The system is designed not to damage the image area. You can see the suction cups are quite gentle. The other thing that you'll recognize is that the suction cups are right on the edge, and if you have like a fast unit, for example, that's the area that would typically go in the clamp of the fast unit. So it's generally not used anyways. or even if it's a solvent unit, a lot of times you have that area where you're going to be punching the plate. So we try and grab that plate with the suction cups in an area where you're generally not going to have images anyways. So having said that, you probably want to avoid having the image right there where the suction cups are, but they are very gentle and they shouldn't really damage the image of the plate.
Great. That was actually one of my first questions when I saw that video too, so I'm glad somebody else asked it. That's it for the questions that I have on the screen so far. Unless somebody else has something else something else to ask, we can move on to the next section.
I want to just mention one question that I typically do get, and a little surprised that it didn't come in here. And that is, around the speed of the automation. I've had people comment to me that, they feel that they could load the plate faster than that machine loaded it, or they could unload it, or they could do all these things manually in a faster way. And my answer to that is always that you probably can. It's not designed to necessarily, move as fast as possible. It's designed to move in a very consistent and secure way to where it's not going to damage the plate. Because obviously, if the system damages any plates ever, it kind of starts to lose its value. But you got to remember the value of automation, and especially in this case, the value really is that the operator doesn't have to do any of that stuff. You saw the operator come in, load basically put the plate there on the CDI and hit one button and walk away. And he didn't have to come back for quite a while to continue that process. So it's really important that when we look at these things that we remember the value of automation.
Yeah, and just to add to that, Rory, I think it's really cool that the XPS gets the plate information from the imager, or from the software that you're sending the plates to the CDI, because then that reduces the risk of exposing the plate with the wrong exposure time, which happens so many times in a plate room. With people that have multiple plate types, if you're using plate type A and you expose it with the times for plate type B, it's going to be a bad plate. So the fact that that's automated as well is a really nice feature.
Yeah, very good point. Were there any other questions? I believe I see a couple that popped in there, guys.
Yes. Brad, can you talk about wiping roll maintenance?
I'm not sure what the wiping roll is. I never heard of that word. If he's talking about the compressible impression sleeve on the FAST 2000.
So my guess would be it is related to the older generation FAST, where you had a central drum which had to be cleaned up, and you had a lot of cleaning related to that. So
yeah, so one benefit that I didn't talk about that these newer generation fast processors have is, in combination with the non-woven material that's absorbing the polymer, there's actually a very thin PET that goes into the machine as well, that protects the liquid melted resin from getting on anything inside the machine. So it actually goes and travels alongside the back of the non-woven to protect from any of that melted resin from going through the non-woven and getting onto rollers in the machine, which happened a lot in previous generations, and that required a lot of cleaning. So this keeps the machine very clean on the inside.
Okay, I got two more questions related to suction cups and plate loading. So the first question for Rory is, can we load partial plates? And if so, how small?
So the current version of the technology does not allow you to load anything outside of a full-size sheet. It's something that in the future we may be able to load a plate that covers the complete circumference of the drum. So in a 4835, that would be the 48-inch dimension. But for sure, if a plate has to be taped, then there's no way to automate that. So What you couldn't see in the video there is like if you want to load a partial plate, you can get very easy access to the drum by loading the entire kind of front part of the machine, and loading it exactly how you would load a regular CDI today. So the answer, unfortunately, is no. I would expect that could be something that we'll see in the future.
Okay. The next question for you, Rory, is about the suction cups. Do we have any idea of life expectancy for those suction cups? How they hold up over time?
I'd only be guessing, really, if I tried to give you some kind of number for the lifetime. You know, it's a relatively inexpensive thing. You know, it's one of those things we'll probably keep an eye on and replace as needed. But I haven't heard anything in terms of, you know, those things wearing out or anything like that. Obviously, it's a newer product, but we have done a lot of cycles in our development process, and that's not something I've heard of as an issue. So, unfortunately, I can't give you a better answer without kind of consulting with the factory, and you know, you're certainly welcome to kind of contact me directly, and I can go a little further with that question and get you a more precise answer.
Okay. Looks like we got another plate handling question here. Let's see. They wanted to know if, as the plate is pulled into the XPS, is there static created, or is there an air pocket underneath, and is that plate totally flat?
In previous versions of the plate handler, we would actually blow air under the plate, and that was because we were picking up the plate from. We weren't actually kind of dragging the plate like what you saw there. We were kind of lifting it from the back edge of the plate and pushing it from the side, and so we'd blow air under it to allow it to kind of float across the table. You saw in the video we didn't do that anymore, and part of the reason for that was when you blow that air into the plate, it does kind of create a little bubble. So now with the new way we do that, we really aren't seeing that issue anymore. And the same thing with static. We really haven't seen any issues there with static either. So, you know, the newer design actually is addressing some of those things. And so is the plate totally flat? The answer would be yes, it is totally flat.
Very good. That's all the questions that have popped up so far.
Very good. Well, I think we're ready to move on to the next part of our session today, which, Sean, I believe you're going to be introducing the speaker there, so I'll hand it off to you.
Okay. So next up, we have Mr. Oscar Buenrostro, one of the application sales managers within Esko North America. And he is going to be doing a presentation today showing us two different Esko products related to the label market on the Flexo side of things. He's going to talk about first Art Pro Plus, our native PDF editor, and then he's going to jump into a little bit of automation engine with a new browser-based interface as opposed to the older Pilot interface. Oscar, you ready to go?
I am. Can you hear me okay? Can you see my screen?
I can hear you and I can see you. Hopefully everybody else can.
Excellent. Well, good afternoon, everyone. My name is Oscar Buenrostro, Application Sales Manager with Esko. Already working with Esko for over 12 years, and I'm happy working with all these amazing products and solutions. So today we're going to focus on two product solutions, Art Pro Plus and Automation Engine for labels. So once we concentrate on these two Esko products, two different products bringing to the same label solution. So we're going to start with Art Pro Plus. Again, aim for labels. So why Art Pro Plus? What makes Art Pro Plus the better editor? So Art Pro Plus is a user-friendly interface, next generation PDF editor. And this interface is a very intuitive And again, working with native PDFs as a prepress editor. Customers encounter some problems when working with native PDFs, especially working from other, graphic editors. So with these problems, it's easy to overlook errors or issues that can lead to waste of time and money, right? So for those customers editing PDFs with Adobe Illustrator, this can open to a world of problems. Actually, this process itself can be a mess when translating or converting to AI, meaning Adobe Illustrator files, or even back as a PDF. Now, the solution for this, by default, our Pro Plus comes with over 200 rules, and customers can add more rules depending upon their printing needs. This process will be performed without destroying or flattening the artwork. And again, our Pro Plus can edit specific elements in the artwork. Our Pro Plus contains the full pit stop engine technology, plus customized actions for any printing segment. Also, our Pro Plus pre-fly functionality helps users save lots of time in every job. The intuitive user interface allows operators to perform complex editing operations without the need of extensive training. And it has some nice features, like here showing the wheel working like compass that I'm going to show you in a moment. And this is to speed up the process for the PDF editing. So I'm going to go ahead and start and show you a quick overview demo of our Pro Plus. And this will be aimed, of course, for labels. So now into our Pro Plus, we can start doing things like move things around, of course, using the wheel, transform elements, for example, move things around. And again, using this wheel, it's kind of like a shortcut to the tools that we most often use when doing pre-press or prepping the file. In this case, it's going to take the densitometer and click on a specific area, like there, it click on an image, and we can see the different values when it comes to different percentages, and that includes in that image. Same thing there, looking at the percentages. And also, one of the things we can do here, of course, selecting the black arrows to select objects. What we're going to do next is going to optimize or clean our label. Now, with this clean and optimization feature, we can do things like among contrast text, outline stroke, or stroke outline. In this case, I'm going to go ahead and use the cleanup groups and clip and mask. What this feature will do is get rid of double lines and use elements, get rid of unpainted objects. So it's gonna optimize this, in this case, clean up 20 items, clean 20 items. So we have now the artwork optimized, getting rid of those elements that they're not needed. Another thing we can do here is this barcode, for example, it has is an actual image. So it's going to show you under the image there, it's an embedded image. We can see it's a CMYK image and it's showing the resolution and everything. But What we need with this label, or for this label, is an actual dynamic intuitive barcode. So we're gonna go ahead and create that barcode out of the image. In this case, it was a JPEG image. Now we extract that information, scanning this image. Now from pixels, we're gonna have an outline barcode, dynamic barcode. And at the same time, we can edit or modify this barcode. So instead of a 3, we need a 6 there. And it's gonna give you like a warning or just a message there. The barcode about the check digit is not, it's not gonna be a 1 as a check digit number 1. It's gonna be an 8 instead. So these are the things that ARPro Plus using the dynamic barcode will be able to fix for us. And not only that, but also we can go over the magnification, the height, the BWR, very important, especially for Flexo, if we need to do that compensation. And in this case, I'm gonna add a box around my barcode. I'm gonna put a specific distance on one of the sides of the barcode, but also I can do the same around the barcode or one of the each side of the barcode. So I have now the box around. There you go. So we have a live barcode. Now we can move to the separations. And one of the things I'm going to show you here that we can do nice and easy is to add a PMS color. In this case, I'm going to add a Pantone green. And the goal for this is I want to be able to replace my Pantone 335 for a Pantone green. So instead of selecting each element painted with the 335 Pantone, I'm going to just apply the same change with a single click through all the artwork in this label. So for that, I'm going to go and select my color palette there and select replace separations. Pick my 335 Pantone to be replaced by the Pantone green. And as you can see, it did the job here, replacing every single element. And there, what I'm showing here, that 335 is no longer part of my separation list because it's no longer needed. But instead, I have my Pantone green showing the separation. And also what I want to do here is selecting these two get set logo elements because I want to put a white underprint and add an extra separation using that white underprint. And from here, I can either choke, spread out, choke in, of course, specify the distance if I want to do around my get set logo in this case. So I'm gonna go ahead and create, and then automatically you will see that white underprint created. And therefore I have a brand new separation, including only in that get set logo. Part of the other tools, nice tool we have inside the ARPro Plus is the quality control. I'm going to show here the Flexo print preview, and this can be also based on different parameters. For example, this first printable dot, in this example, I'm using a 1.2. That's going to be my minimum dot, again, for Flexo. And this one, talking about dot gain, will go up to 12.2. But again, this you can do this based on a fingerprint, so you can calculate the dot gain. I'm gonna go ahead and zoom into this the picture, select my zoom tool, zoom to the apple here, and I can see the difference between without dot gain and with dot gain. So I can see darker areas simulating the dot game. Same thing with the breakouts. I can see right away breakouts, meaning if my first printable dot, it's a 1%, below that percent, it'll show me highlighting in blue. So either I have the opportunity to go and fix this inside Art Pro, or if it's an image, I can go to Photoshop and make the adjustments. Same thing for the total area coverage. It is important, especially going to press. In this case, I'm using a limit of 250%. Beyond that or higher than that is going to be highlighted in blue, meaning I have more than 270%. So it's a nice quality control, because sometimes if we have too much ink on specific elements or objects, can be translated and drawing problems on press. Now from here, I'm going to take a look on, again, my separation. I see the white underprint, my white opaque, and then I can either save this as a PDF, or in this case, what I want to show you is I'm going to launch this to Automation Engine, which is going to be my second product or solution that I want to show you today. So launch workflow right from Art Pro Plus is going to give me the ability to connect to Automation Engine. What I'm looking at here is the different workflows inside Automation Engine. In this case, I want to use a specific workflow I have prepared, called Create Product. And here I have the material and the product name, but I can add more fields with the public parameters. So in case I need to put like the size or anything else different here, I will be able to put that part of the customization. So I'm going to leave this as a paper and add the product name. Now, the goal from here is to create a product right from Art Pro Plus going to Automation Engine. And what a product is. So a product in Automation Engine are those one-up pieces of artwork files. And I'm going to show you that in a moment once we move over to Automation Engine. And I'm going to click Launch. From here, I come to the end of my Art Pro Plus presentation. From here, we're going to move over now to, again, Automation Engine. Automation Engine Quick Start for labels. And this is going to be the browser base for Automation Engine. So what is Automation Engine Quick Start for labels? You can see here with the interface that I'm going to show you in a moment, it's a very streamlined, slick interface. So for those of you that are familiar with the Automation Engine Pilot, this is a new skin. So that new skin, for example, this is a new browser-based interface, like I mentioned before. And what is nice is this interface is tied to a pre-configured workflow solution. And at the same time, this turnkey solution for label converters can be installed and trained in only 5 days. This is what is nice about this. Not only streamlines, but the implementation process is very quick. Now, Automation Engine, browser-based or the Quick Start solution for labels, is a pre-configured automated workflow solution. simplified user interface, like I mentioned before, designed for consistent result through the things like report generation, automated trapping, and pre-flighting, just to give you a few examples. And of course, it's all about reducing errors and saving time, which at the end saves money, which is very important. So let me go ahead and move to show you demo the Automation Engine Quick Start for Labels solution, browser-based. So from here, as you can see, I have the browser showing that I have my address there. I'm gonna log in to Automation Engine. I can see now the product that I sent from RPro Plus over to Automation Engine. But what I would like to do is also add a new product. And again, products in Automation Engine are those one-ups pieces of our work files. So this is another way of bringing or creating a new product or a new one-up. In this case, I'm gonna drag and drop a file. Now I can see this one's not gonna be the green one like a brought from RPro Plus, gonna be the orange one. I'm gonna rename this product. Now that I have the name, I can have a reference or description. In this case, I'm gonna use the front label as part of the description. Important, I wanna add the material. I have here a few materials. I can add more or add as many. In this case, I'm gonna select paper, same as I did from RPro Plus. And here you can select the winding direction as well as orientation. It's gonna show you that in that small thumbnail. Going to customer, select the customer, which is important. Now under prepare, I wanna select the Automation Engine workflow for this particular one. Pre-flighting, yes, I wanna do a pre-flight, and also when I get a report out of the pre-flighting. And remember, this is using the pit stop technology. Same thing, I will be able to select the number of separation if that's something that I want to make sure there's on this label no more than eight inks, for example, or 8 colors. Talking about the pre-flight report units, I'm going to use inches and of course English as a language. Trapping, yes, put the trapping distance. The proof or the print card or spec sheet, also another thing I want to create within this workflow. So yes, I want to have that report or this proof, and click to start preparation. So this is going to start the product preparation process. I can see that working in progress, preparing. So the first one I'm expecting to have is the pre-flight report. I have a notification, or I can go to my to-do list there. Please check the pre-flight report. I'm gonna go ahead and open that report. Here, this is a PDF report. It's a multi-page PDF. As you can see, it's 10 pages. And part of the results here from the report have a couple warnings. If there are some errors, I have or will have the ability to go back to RPro Plus and fix those errors. But what is nice is this pit stop or pre-flight will flag those violations. So in this case, again, I have a couple warnings like black text does not overprint, so it's not big of a deal. So I'm gonna continue, but I'm gonna show you also other pages within this report. It's a very complete report, so everything looks perfect, even though with the warning. So I'm gonna click continue. And then the next step will be trapping. So that's part of the things I request from the beginning when I create this project or product, I'm sorry. So I have that ready. So I'm gonna check the product. And part of the things I wanna check, I'm gonna use the viewer inside automation engine. And one of the things I wanna check here is trapping. So again, that brought me to the viewer inside automation engine. Quick start for labels. And so of course I can zoom in. I want to check that trapping I was mentioning before. Zoom in and I can see, yep, there's trapping, looks good. And of course other tools here, I can zoom out. That navigator is a very useful, so I can move around my label using this navigator. Can use the hand to pan around, move around. Other nice features like I can make a mirror. So for those jobs that it's internal or inside printing, if I want to proofread, I can make a mirror, use a ruler. And again, this is a QC tool, the viewer inside the automation engine. So not only using the ruler, not only to check the distance, but also the angle. If that's something I need to check in this label. The eyedropper, so I can check color or the percentages in this image, in this orange, for example. But not only the color in percentages, but also it's going to give me information about the line screen and angles. Moving over, selecting now the barcode. I'm going to scan this barcode, and again, as a QC tool, I want to make sure I have the right number or if it's readable, right? So right there, give me all the digits for that EM13 barcode. And of course, I can double check my separation right from this viewer. Again, part of the QC or the quality control process. So everything looks good. Looks perfect. Now I'm gonna move to go and say product okay. And then next thing is gonna do part of the this product creation is gonna create the proof or spec sheet or print card. This proof will be also a PDF file. So I can now move under my to-do items. Please check the proof. Same thing, I'm gonna use a viewer, or I can open this same file using Acrobat if needed. And this proof we're talking about here, this is again, multi-page PDF, 3 pages. So again, it's a spec sheet. I can see relevant information about the file name, date. I have a screenshot of the actual product. And by the way, we can customize. I'm looking at the rest of the pages, see the separations. And I was going to say that this report or proof can be customized. So of course, we have the Esko logo there, but we can use a customer logo or make a few changes to this template, this proof template. So again, right there is showing different view modes that we can use within the viewer. So everything looks good. We can actually send this proof out to our customer or internally in one of our departments here. So looks good. I'm gonna say proof okay. And now we come to my new product. It's ready for production. So again, I can keep adding new products. So in this case, I'm going to select these two labels, get set labels, the green and the orange, because I want to do a combo layout. So I'm going to go ahead and select those two products, labels, add it to my cart, because these two products are ready for production. I want to enter the quantity for each of the labels and create production job. I'm going to use a Flexo workflow. Of course, I can add a product or production job name. In this case, I'm going to use test job for Flexo. Moving forward, going to output. Again, I'm going to select that specific output to do the step and repeat, the layout. Now, this layout will be created based on a die or a template. In my case here, I have 3, but again, we can add as many as needed. So I'm gonna select this die. And put the roll width. Die on roll, we can center in the roll, put it towards the left or the right. I'm gonna do center. Number of rows, again, part of the die, in this case is 4. And I'm gonna add marks or a mark set. So all that list I'm looking at there are different mark sets, meaning I can customize those marks. So if a particular customer has a very specific set of marks, that's something we can customize. So here I'm gonna use this one that I created, it's called Labels, Flexo, which include bearer bars, registration marks, and things like that. I'm gonna move over the printing sequence. I'm gonna do the autofill. I have my A and B label, meaning the A is the green one, the B is the orange one. I can also drag and drop if I want to invert that order, for example. And another nice thing I can do is add print finishes. So if you want to add embossing, a foil, or things like that to my label, we can go ahead, or I can go ahead and pick that from my separations within my artwork and treat that as a special print finish. I'm not going to do that here, but I'm going to start production based on those settings I just entered, grabbing those two labels, the green and the orange get set labels. Now, I'm going to create that layout. And to show you that, this is something I don't need to do as a customer, but just for you, for demo purposes, to show you what's going on behind scenes, what's going on under the hood. Those of you familiar with the automation in pilot, this is the pilot version. And again, me as a customer, I don't need to go to the pilot, but I want to show you what's happening here, what the workflow that it's doing. So if I open the workflow, you will see a different series of tasks, from pre-flighting, trapping, creating that report, everything automatically. And of course, that process create a job folder. Again, test job for Flexo, that's the one I did from the browser version of Automation Engine. And it's still processing. Once it's done, I'm going to show you the end output file. So there we have the press ready output file, again using the viewer now from the pilot version of Automation Engine. And I have now my layout with bare bars, swatches to check densities, probably that gain part of my quality control, registration marks. And again, those marks can be customized based upon the customer needs. And from here, I can either send it over to my RIP, Imaging Engine, and then from there to my CDI and have the lens files out. So here it brings me to the end of my Automation Engine browser-based Quick Start for Labels demo. If you do have any questions, we are all yours.
All right, Oscar, not a lot of questions so far, but well, I think you kind of covered this when it came in earlier. Does the AE browser completely replace the pilot?
It's another approach, another way. In this case that I showed, the browser-based Quick Start for Labels, it's a pre-configured solution, but you can still go to the pilot and do like edit the workflows or even launch a specific task right from the pilot.
Exactly. And for those that were familiar with some of the earlier Quick Start from Esko, these workflows are not completely locked down. You have the ability to go in and edit your own and create your own on top of them to use through the pilot. So the browser base is just an add-on. See, another question here was, is the new browser capability approved for use over the internet or across a WAN internally? Oscar, if you don't mind, I'll answer this one.
Yes, please.
Okay. So effectively, no. The browser is still much like the pilot. It is an internal LAN only solution. We do have a solution to drive Automation Engine via the web from remote facilities. Currently today, you can do that with Web Center. In the future, we are working on more of a web-based version of Automation Engine. It's in its infancy right now, but it is definitely on the drawing board. But as I said, you can completely drive a Automation Engine from one or more remote sites via Web Center today. Absolutely works well. Last question that I have here is, do I need to purchase a separate license for pit stop functions within Automation Engine?
No, that's part of the processor module inside the Automation Engine.
Exactly. All right. Any other questions today? Oh, one just came up in Spanish, and unfortunately, I don't speak Spanish natively.
Okay.
There you go.
You can try, Sean.
I could try. There you go. She was kind enough to translate it for me. To work with label and flexographic process, what percentage is it advisable to replace Adobe Illustrator with Art Pro Plus? Okay. This is a matter of, Oscar, if you don't mind, I'll answer this one. I'm sorry. Working with Art Pro Plus versus working with Illustrator, it's really a matter of how do you want to work. Do you get 90% of your jobs in natively in Illustrator? Then I would probably recommend continuing to work in Illustrator. If you get in PDFs that you have to go back and edit, pulling them into Illustrator is a terrible idea overall. And even Adobe will tell you that Illustrator is not a PDF editor. So in that case, if I'm getting in PDFs, then definitely I would want to go into Art Pro Plus. That way I'm keeping it native PDF in a native PDF editor rather than turning it back into an Adobe Illustrator file. Now, this is kind of a fine line because Esko actually offers the ability for customers to import PDFs into Illustrator via one of our PDF import plugins, which keeps a lot of the native information, a lot of the metadata from the PDF available into your Illustrator file, so you can go back and work with it without screwing up things like text flow and links and your layers and all that kind of stuff. But the true advantage of using Art Pro Plus with something that is a PDF already is that all of your PDF layers are maintained. All of your clipping paths are maintained. All of your naming and all that kind of stuff is maintained rather than being flattened and ruined when it gets pulled into Illustrator.
Yeah,
There's also-
that was a good question. And also just to add what Sean said, with our Pro Plus, you can still open Adobe Illustrator files. And in my opinion, Adobe Illustrator, it's a great product, especially when it comes to designing. Of course, many pre-press people use this as a pre-press, graphic editor or Flexo prep or digital prep Illustrator application. But our Pro Plus will give you all the power to do those pre-press specific needs or tasks where Illustrator don't have that capability.
And we just barely touched on the capabilities of Art Pro Plus. Honestly, today we didn't get into any of the 3D stuff. We didn't get into step and repeat. We really didn't get into any of the powerful functions that you can do by creating action lists. What else did we do? Creating cut paths, any of that kind of stuff. We didn't get too deep in Art Pro Plus at all today. If you guys have more questions, by all means, feel free to send us an email or post them up here. Any more questions for Oscar before I close this off? Questions for Oscar, Brad, or Rory are welcome.
Open floor.
Yep. Otherwise, we're going to call it quits a little sooner today than expected. So, you all were invited automatically to tomorrow's presentation, day 2. If you did not get an invite to day 2 via email, by all means, please contact us at info.usa@esco.com. That's info.usa@esco.com. And we will resend your confirmation for tomorrow's presentation. Checking my questions one more time just to make sure we don't have anything additional. Don't see any new questions. So unless something pops up, I think we can call this a day. Thank you all for your participation, and we'll see you tomorrow.
Thank you all.